Welcome, folks. Where are we? We are in the English countryside. We're flying live time and live weather, and I can't do that from Minnesota. It would be very dark and very cold. So we're here in Europe. We'll take a look at the scenery. The Leeds-Bradford airport is Payware's scenery. I forgot where. I do remember the source. This is Orbex's scenery. And look at this. We're on a hillside here. We're on the top of a hill. You can see some wind turbines there just ahead to the left. And you can see how this drops down into a valley. I have never been to England. Our destination today is Dusseldorf, Germany. I've also never been to Germany. I have been to Europe. I've been to the Mediterranean. But I've never been to England. Here you can see this is very common in Europe, especially in smaller regional airports where you're asked to do what's called a back taxi. You'll actually taxi onto the runway in the opposing direction from your intended takeoff and then do a quick little U-turn to take off. Not so common in the United States. Got some little trailer park down here. This looks like a little trailer park. Maybe it's a trailer manufacturing facility. Yeah, you can tell it's England. Look at how terrible people park their cars. No, I'm kidding. Oh, I'm so sorry for that. But this is a detailed airport thanks to Orbex, and in my experience, Orbex just does a masterful job at these airports. Oops. Leeds-Bradford Airport. There you can see it there on the tower. Got some nice advertising here on some of the signs. Really bad parking. I'm surprised we don't see a couple of folks wandering around looking for their cars or looking for their keys. Got a couple of Jet 2 airliners, one from Ryanair. And here's our trusty steed today, an A320 Airbus. This one belongs to the German Air Force, the Luftwaffe. Luftwaffe, I think, is a German word that just means Air Force in general. So it's the Deutschland Luftwaffe. I don't know if they, in Germany, if you put the noun before or after the adjective. So it's either Luftwaffe Deutschland or Deutschland Luftwaffe. Anyway, let's get out of this showcase mode. We go to an external view. There we are. Looks like we've got some ground personnel ready to assist us. So let's get this airplane ready for flight. get the jet bridge attached. You may have noticed that left front entryway door just opened as well. We'll get the baggage started, baggage loading process started, and we'll hook up some ground power. Did you notice how the power truck had to jinx a little bit to get into position? I bet that baggage conveyor will also jinx a little bit to the right to get a more square on position. Let's watch him. Let's see if he jinxes a little bit. I bet he will. He'll do a little Super Bowl maneuver. Oh, there he goes. Not quite perfect. But I love the animation. I love the addition of ground crew. This really, in my opinion, it really kicks up the immersion level. Historically, flight simulators who have attempted to work on the ground handling, they're pretty good at adding vehicles, but they, until recently, never bothered to put in people. So let's take a look at our flight. If you've flown with me before, you know that I've got a couple of friends, and my friends are SimBrief and the A320 Takeoff Performance Calculator. And these are really going to help us in our flight planning. So what I want to do, let's flip these around. I want to go to the Takeoff Performance Calculator first, and then to SimBrief, because remember, whatever we add into SimBrief is going to be automatically imported into our flight computer thanks to the most recent, not the most recent, but thanks to recent modifications to the aircraft. So here we go. Let's go to weight and balance first. We are flight number 43. Our destination is Echo Delta Delta Lima. We have 2 flight crew members and 4 cabin crew members. We're in an airplane with a 180 passenger configuration. We have a low demand today. Basically, we're carrying German government officials. This is a German Air Force airplane. So baggage is low and no cargo. Let's generate a random load. It's given us 142 passengers out of 180. That's actually, for a low load, that's pretty full. But we don't have many bags. And here's our performance envelope. You can see we are nowhere near our gross takeoff limits, and we are well within the flight parameter envelope. So that's exactly what we like to see. We have a stabilizer trim setting of 0.04 up. We'll remember that for our takeoff calculations. Let's go over to the takeoff section. Our origin airport at Leeds-Bradford is Echo Golf NM. Now, me, from an American perspective, when I see the initials NM, it makes me think of New Mexico. And looking around the English countryside, this looks absolutely nothing like New Mexico. So, oh well, Echo Golf, New Mexico. Let's take a look at outside air temperature. Well, we certainly do know what that is. Let's pull up our current conditions here. Temperature is -2 degrees. That's a cool day. If that were Fahrenheit, it would be a really cold day, but it's centigrade, Celsius, so it's cool, but not monstrously cold. Pressure setting, well, this is in the North American standard. Oh no, there we go, 1018. 1018 in hectopascals, not inches of mercury, which would be the North American standard. Wind is at 6 knots coming from 020. 020 at 6. We're going to be using a flap setting of 1+ because we have nice long runways here. Actually, let's go with a flap setting of 2. No, 1+ is fine. We have not only do we have fairly long runways, but we've also got a light load. Packs will be on and ice off. The runway is dry. Stabilizer trim has already been added in for us. Let's choose a departure runway with winds at 020, 14. Let's see. 020. Goodness. 14 or 32. They're both runways are going to have a crosswind component. I'll go with 32. Full length. And let's calculate. There we go. Our flex temperature today, the temperature we're going to add it to the computer to trick. We're going to trick the computer. We're going to pretend that the weather is not -2. We're going to pretend the weather is 60 degrees centigrade, and that's going to make the aircraft not perform as hard as it might otherwise. This will increase engine life and also help out with noise abatement, keeping the English countryside quiet for our Leeds-Bradford neighbors. We have done all the flight planning on our takeoff calculator. Now let's transfer that information into SimBrief. So I'm going to leave the airline blank. You may remember from my last videos, if you add a airline in here, the air traffic control will often give you a double identifier. For instance, on the last flight, we were Frontier Airlines, and if I typed in the code for Frontier, you would hear the air traffic controller say, Frontier, Frontier, Flight 43. Well, we don't want that double identifier, so we'll leave that blank, and then the only way the simulator knows that we are our flight is from what we tell it. Actually, you know, that's a really good point. I don't think I told. I have to go. Excuse me, folks. I think I need to do a little housekeeping here, because I don't think I told the flight simulator what our airline was. Our airline is, because we are a German government airline, our call sign is GAF, which is pretty simple. It just stands for German Air Force. But I did not tell that to the flight simulator. So just a bit of housekeeping. Yes, had I not addressed this, we would have still been known as Frontier. There we go. A couple of add-ons we're using are the same as last time. Pilot to ATC is our air traffic control and 2 programs from the company called, what is that company called? They're really great programs, Pushback Express and A320 Flight Crew, and they are from a company called FS2Crew. Give them their chops because they are well deserved. You know, one of the slogans of FS2Crew is, you don't fly a commercial airliner by yourself, so why simulate the aircraft flight by yourself? And to have a virtual first officer there to handle the radios and to run the checklists really, in my opinion, really kicks up the immersion level. Now you can see one of the airports here is a one of the runways is a modern runway, and the other one is looking kind of down in the dumps. So I imagine the good runway is the one that gets used. Let's go back and get the jet bridge reattached. We can get the baggage handled once again, and we'll get that power supply back on. Okay. Thank you for letting me take that little diversion. Oh. Our aircraft type is an A320. Now, the standard A320, not the Neo version, the new engine version, is down here in this population list, A320. A couple of intrepid folks, I don't know who they are, modified the parameters to make the performance much closer to the Neo model. And that's this A320 that's loaded here at the top. I wish I could give proper credit to the folks who've done that, and I wish I could reference where I got that. It was a while ago that I acquired that modified aircraft type that more closely mimics a 320 Neo model, which is the one we're flying today. We want to add in our zero fuel weight from our weight and balance, which is 55.5. We want to add in our number of passengers, which is 142. Remember, the airplane won't get any information at all from the takeoff calculator. All of its information will come from SimBrief. So gotta transfer these over. 142. And the default route it's given us is the LAMI 2W departure to LAMX on an airway, the L603 airway, to LAMSO, to EVLI, to the PAM VOR, to the P62 airway, to Tebro, and then the Tebber 1X arrival. I must say that in the United States, these departures and arrivals have much more pronounceable names. I think they go through an effort to make them more like words. Of course, you know, every waypoint is a 5-letter identifier, and it's common in the vernacular to turn those 5 letters into a word, even though it's may not really be a word. Some of them actually are words. When you see a 3-letter identifier, that's usually a VOR, a very high omnidirectional radio signal, or a radio antenna. And then when you see something that starts with a letter, like P62 or L603, those are airways. Airways are a combination of waypoints. So maybe an established airway might be 4 or 5 different waypoints. And instead of listing them all out individually, you just identify that airway segment. So that's what that is. Anyway, if we didn't like that routing, we could choose other suggestions. To be honest, I don't fly in England. I've never been in England. I don't know much about England. I'm going to trust that the default routing is a good one. I certainly can analyze the routing. We'll push the Analyze button, and it says the route is valid. So we can, before we actually accept it, we can even do this. We can even look at the map and see if it kind of makes sense. Here we are in the north central England, and over the channel, over a wide section of the channel, over Amsterdam. EHAM, isn't that that's the Stoffel, the big airport in Amsterdam? I don't forget what it's called. Steppel, I think it's called Steppel. And then that's actually that. I don't know what our alternate is. That would be a good alternate. And then kind of a hook maneuver from the north, and then a hook maneuver, and then approaching from the east to the west to Dusseldorf. Let's take a look and see what our alternate assigned was. EHAM, yes, that is the Steppel Airport. Perfect. EHAM is right here in Amsterdam, and that's a really good alternate. Okay, so I'm going to choose to create or generate operational flight plan. Wonderful. That is done. And because it has been directly imported into our sim, you know, before we had the ability to do that, I would certainly review the block fuel and the gross weight and the center of gravity, and I would review all that, but now I don't have. Here you can see our route just as we looked at it. And it's got this, there's PAM. I'm not sure what this identifier is. And 0355 Foxtrot. But I'm going to trust that it's the same routing that we saw before we generated. Certainly looks the same. So let's minimize these, and we don't want to totally close them out because we're gonna want to. Actually, I can probably remember 0.4 up on the stabilizer trim and 60 degrees on the flex temp, and we also have our takeoff speeds 130, 130, and 131. So I'm just going to minimize those just in case I forget. We'll have access to them later. Here we are on the flight deck. Let's get some power. I want power, baby. Oh. Some of my view control buttons don't seem to be working this morning. I'm going to do another bit of housekeeping. My view control buttons don't seem to be working. I'm going to take a look and see what's up. If you know what an Orbweaver is, I use a Razer Orbweaver to control my views. Let's, oh my goodness, my Razer Orbweaver isn't even identified. Maybe that's why it's not working. So here I'll go through my views. Everyone has a mouse. That's one controller. My other controller is a Microsoft Gamepad, and this is used for those showcase views, the ones of the English countryside and the terrible parking in the parking lot. And then I have my throttle quadrant, which is used for looking outside the airplane, spinning around the airplane, looking at the jetway connection, looking at the ground handling. And then I have my TCA. This is a Thrustmaster Civil Aviation Edition throttle. And this is what I use to control the engines, the starting the engines. I also have the add-on pack for the speed brakes and the flap setting and the parking brake. All of that is handled through the TCA Thrustmaster Civil Aviation. And then my main control, my buttons for air traffic control, my buttons to push to talk so I can talk to the ground crew, all my yoke movements, other controls are on what's called a VKBSIM Gladiator joystick. And then the final control that I am not seeing is the Orbweaver, which is basically, it's I'm going to step away from my seat here for just a bit and check the plug-in. This is it's just a set of extra keyboard buttons that I can assign different functions. And what I've done is assign them to views. Okay. "97% of the time, if you have a control issue, one of the great fixes has always been just to unplug the device and plug it back in. So that's what I've done. And I still don't see that device. Okay, well, it's very inconvenient not having it. But I will continue on. So this is going to have to be how I access the overhead panel. Actually, in a way, this is more realistic because, you know, when I'm using the buttons, I look at the panels square on and straight up, and that's not very realistic. When you're really flying the airplane, you would turn your head to the right and you would crank it up. So, I may have accidentally moved my camera there while I was fiddling with that. But as you turn your head to the right and crank your head up, this is a more realistic view of what the panel would look like. Now, again, I'm not used to seeing the panel necessarily from this angle, so it might take me a little bit extra time. But here we are. Let's turn the batteries on. We got batteries number 1 right here in the center. As you do a flow from left to right and from bottom to top, there's the number 1 panel, the left panel, then this big middle panel, and then the right panel. In a Boeing, of course, you'd have, I think there's at least five vertical panels, but here in the Airbus, there are only 3. So in the center of the number 2 panel, I'm going to hit battery number 1, turn that on, and you can see there is no indication on the button, and that's typical for Airbus. When you see no indication on the button, that means the button is in the normal setting. Now, most of the time that means on. It could mean off. Sometimes you'll see a button, it'll have illuminated the word on, which that's not the normal setting. The normal setting might be off. But blank means the normal setting. And have you ever met a NASCAR race driver or been in a race car, and when they position the dials on the instrument panel, they're not always straight up and down, so you can read the words. What the race crews often do is turn the dials in a way so that when the racer is at full speed, all the arrows point in the same direction. And that tells the he doesn't have to read a number. He doesn't have to look at read a word. He just sees the needles are all in the same direction, and he knows that everything is okay. Well, same thing in an Airbus. When you're flying, you look up at the overhead, and all the indications are blank. And if you see blank, that generally means everything is okay. When something is illuminated, that means there's something wrong with it. So in a way, it's very intuitive, but you also need to know that that's what's happening. There is no on illumination. There is no off illumination necessarily. When you see a blank button, that means it's normal. So battery number 1 is in its normal position. Battery number 2 is now on. And I can go down here to external power. Now you see it's available, and we'll go ahead and push it, and it says on. Now on, when I'm flying, that's not a normal indication. So even though there's nothing wrong with having external power on, that doesn't mean there's a fault. It just means because you're looking at something that's not normal for when you're flying. Okay, we have battery power. Let's say that we have low air pressure air conditioning coming from the terminal connected by the jet bridge. Our packs are not running, our air conditioning packs, so we're not getting air conditioning from the aircraft yet until we turn on the APU. But I'm going to turn up the climate controls for that low air pressure coming from the terminal, and eventually the air conditioning will be provided by the aircraft, or by the first by the APU, the auxiliary power unit, and then by the aircraft. So we have our temperatures turned up. We're going to turn on the emergency, I'm sorry, we're not going to turn them on. We're going to arm the emergency exit lights. You can see that this switch is in the illuminator is in the off position. So we'll arm the emergency exit lights. Again, the light goes out, that's normal. Turn on the no smoking sign. Turn on the seatbelt sign. Turn on either nav1 or nav2. Those are redundant systems. Turn the wing lights on. We're going to leave the beacon light off. This allows ground personnel to continue working below the airplane. Arm the strobe lights and go up to our inertia reference system, our EDDL system, and we're going to turn nav1, system number 1 to nav, system number 2 to nav, and system number 3 to nav. And those will take some time to align. We'll turn the crew oxygen supply on, and we'll do a fire test on the APU. We're going to be firing up the APU here in just a little bit. Wonderful. And we'll do a smoke test for the cargo area. And that is satisfactory. Let's go down to our flight computer. Oh, I don't have a button for the flight computer. This is going to be very interesting today. Again, this is how you would, if you've watched my other streams, the flight computer's always been square on the screen. Well, that's not how you would see it in real life. You would often see it by looking to your right and then looking down. So this is a more realistic view of the flight computer. Let's turn up these screen rheostats while we're down here. First thing I'm going to do is go to the ATSU menu and then to our company menu. This is all for talking with my company. And different companies will have different setups and different variations on what these screens look like. We'll go to our weight and balance button, and we will send in a request for that operational flight plan that we made up in SimBrief. There it is. Block fuel, 6,300. Again, if I look at my EFIS screen and push the fuel button, I can see I have way more than 6,300 kilograms of fuel. I'm up at 9,460. So we don't need that much the luxury of flight simming is that you can actually defuel your airplane. You can defuel an airplane in the real world too. It's just very inconvenient and it's not done very often. Okay, so now we have a correct block fuel. We'll go to the, we're on page 1 of 2. We'll go to the next page using the right arrow key in the lower right corner of this keypad. I'm sorry, lower left corner of this keypad. Here are our 142 passengers, our zero fuel center of gravity, and our zero fuel weight. Here's the distribution of our payload, and we will load the aircraft with those parameters. Let's go back to the company menu. I'm not going to, in the past we've requested weather. I'm not going to request weather today. You saw that we're under visual flight conditions. In the United States, we would call that CVAC, a clear, what does the CVAC stand for? Clear visibility, clear skies, visibility unlimited. Anyway, so good clear day. I'm gonna take a chance and just not ask for any weather today. I know I'm such a rebel. Data button, aircraft status, verify our engine type, verify our AirAx cycle. Again, we are out of date. And our secondary database is also out of date, but we know that. That's fine. We'll go to performance. Here's where we need some of those numbers from our takeoff calculator. We will enter our flex temp as 60 and our stabilizer trim as 0.4 up. Flap setting of 1. And I think we said our runway was 3-1, didn't we? My brain is mush. What runway were we using? 3-2, runway 3-2. I was close. Actually, I don't know if I can enter it here. Let's go to our flight plan page. Okay. Initialization page. I'm sorry. Getting ahead of myself a little bit. Initialization page. There we go. Leeds-Bradford to Dusseldorf. Flight number 43. There's our alternate. I believe that's that Steppel in Amsterdam. You remember that I like to fly with an aggressive flight cost index to get there a little faster, even though it's not quite as economical. Our ideal cruise level is flight level 330, flying east, and east is odd, so that we have an odd flight level for flying east. There's our center of gravity and zero fuel weights. We don't need to do any, we can push the fuel planning button and we can confirm that, but that's not the fuel that we have on board. You remember our fuel on board is 6220. So that's what I'm going to tell the airplane. Now we have no extra fuel with that block fuel number. I got to do this in a language that the computer understands. I have to say 6.2. There we go. Now you can see, in addition to having all the fuel that we need, we also have a little extra fuel. That's good. Okay, let's go to flight planning. Our departure airport, our departure, and runway 32. And do we have a procedure? Let's look and see if we filed a procedure. I don't remember. It was so long ago. Yes, we have the LAMI 2W procedure. That's why you only minimize those instead of getting rid of those, because you might need those later on when your memory gets shot like mine is. Okay. And, well, I was going to say, in real life, you might not even plan the arrival until you're in the air. But I'm here and it's easy. So let's do our arrival. Okay. I want to be able to file our flight plan with air traffic control, and they won't know our flight plan unless we tell it to them. So remember, when you're using Pilot to ATC, what it wants is your departure airport, which is, oh, come down here. Echo Golf, New Mexico. And then it wants your procedures, but it doesn't want the SIDS or the stars. So we're going to copy over. We're going to leave out that SID, the standard instrument departure, and we're going to leave out that star, the standard arrival route, and we're just going to push copy and then paste. And then the last thing is to add in your arrival airport, EDDL Dusseldorf. Okay, import. Let air traffic control chew on that for a little while. Let's validate that flight plan. And let's file that flight plan. Oh, tells me I cannot file until I'm connected to the simulator. Well, that is easy to remedy. We just connect to the simulator. Here we go. Arrival is runway 23 left in Dusseldorf. And the procedure is the is it TEB 23? Does that make sense? Let's take a look. The procedure was the, yes, Teber 1X was the procedure. Now, as you know, there are different AIRAC cycles, and both pilot to ATC and the aircraft are working on different cycles. So the end part of this procedure number might be a little different. Pilot to ATC says this is Teber 1X, which is older than Teber 3G because the flight simulator has a more updated procedure. Now, in the real world, you would never fly with procedures that didn't match, and we're not on the current AIRAC cycle. But in the honest truth is, every 28 days when they update the AIRAC cycle, there are literally almost no changes. So the Teber 1X and the Teber 3G, for all intent and purposes, are identical. They're using the same navigation aids. They're using usually this, most often the same frequencies. There could be a very, very, very small difference, and that's when there's a very small difference, you change out the whole procedure and give it a new number. So for our purposes, Teber 3G and Teber 1X are the same thing. So we'll enter that in. And let's take a look at let's go back to performance. Okay, so there's our runway 32. And now, transition altitude in Europe is different. I believe Germany is 7,000 feet for the whole country. I don't know what England is. So I'm going to put in 7,000 feet as our transition level. And we calculated our V-speeds using the calculator. I believe they were 130, and here we are, 130, 130, and 131. But again, the airplane is a Neo model, and it's slightly different than the performance here. So we could do one of two things, and they would both be correct. We could type in 130, 130, and 131, or we can just go ahead and let the airplane select them. And you can see they're very close to 130, 130, and 131. So that's fine. We are all set. Oh, my goodness. Here's one of our cabin crew. Okay, we're going to get the cabin set up in the back. I got to get used to not having these view buttons available. Let's go to in the Boeing, this would be called an MCP, or a Master Control Panel. There's a different word for it in the Airbus. I forget what that word is. Flight director on, constraints on. We'll go to max brake. I'm going to turn on the progressive wind shear system here. I'm going to arm the speed brake. I'm going to turn up some of these rheostats. Remember, we did that for a couple of them earlier. And let's get our clearance from air traffic control. Leeds clearance delivery, Golf Alpha Foxtrot 43, ready to copy. Leeds clearance delivery, GAF 43, ready to copy. Here you can see what I'm looking at on the other screen. Here's a map of our routing, and we'll have our little airplane icon follow us along. Here's our nav log, and here's a written transcript of our radio communication. So let's say that I missed something in our clearance. I can go back down here and I can see cleared to Echo Delta Lima. I can find out our departure runway if I missed it. I can find out what the squawk code was or what the air pressure was. So this is awful handy to look at. You're not seeing it because I keep it on the second screen, but I have access to that. I also have a very efficient first officer, and I know that if I forget to type in the squawk code to our transponder, I know she'll do it for us. Oh, she did not do it for us. Oh, my goodness. My first officer let me down. Let's see what the squawk code was. 6653. I'm going to turn the system to auto mode and turn the selector to the TA or traffic advisory mode. Then right before takeoff, or at least when we're pushed from the gate, we'll switch it over into TARA or traffic resolution mode. Speaking of first officer, let's get our first checklist out of the way, our pre-start checklist. That's our first procedure, or that's our first checklist, rather. My buttons really are not working. I can't even go outside without switching cameras like that. let's fire up the APU, or the auxiliary power unit. Little turbine jet engine tucked into the tail of the airplane. It's not used for propulsion, but it can provide an electrical source, and more importantly, it provides high pressure air, or called bleed air, and that's what we'll use to start the engines. So we'll turn the master switch on. Oops, not that master switch. We'll turn this master switch on. We'll count to long 3, 1,000, 2,000, 3,000. We'll push the start button. We'll push the APU bleed air button, and we'll turn on all the fuel pumps. I mentioned in an earlier stream, there have been occasions where pilots have taken off without the fuel pumps turned on, just on gravity feed. It can be done, but you certainly would never purposely fly without the fuel pumps on. Okay, let's do a fire test on the... We already did a fire test on the APU. Let's do a fire test on the engines. I also want to do an annunciator panel test. And this is something I did not do in the earlier stream, but you always want to move this annunciator light into the test position. And what you're doing is you're looking for any element that might not be illuminated. Checking for a bad bulb. An annunciator test. And there's a similar test on the Boeing. You can see every LED segment is illuminated. Every light in the house. And there's a similar test on the Boeing, but it's always good to do an annunciator light test. Very good. Shortly after you turn on the APUs, you should see this flap open indication. You can see the APU coming to life. And then when the voltage has stabilized, you'll get the available indication here. And once you get that available indication, you can go off of external power, and we can go back outside and tell our ground crew that they are no longer needed. Flight deck to ground. We will be ready shortly. Confirm all ground checks are complete and we are cleared to pressurize the hydraulics. Thank you. We have our load sheet. Let's lock the cabin door. Well, you may have not heard that over the radio charter, but I just gave my welcome speech to our guests. Not too much longer in the boarding process. Folks are aboard. Let's push the jet bridge away. Oh, there it goes. I didn't even ask it to. I guess the cabin crew took care of that. Make sure that cabin door is closed. It is. Okay. I had mentioned in an earlier stream, one thing that's not simulated is the permission to push back and engine start. So I need to simulate that. So here we go. Actually, I stand corrected. When using the default air traffic control, that request is simulated, but we are using pilot to ATC. So we actually do have the ability to make that request. So let's do that. Make sure I'm on the correct frequency. They don't seem to have a ground frequency at this airport. They do have a tower, so we will talk to the tower. Leeds-Bradford Tower, GAF4 tree, request pushback and engine start. Flight deck to ground. We are ready for pushback. We are ready for pushback and engine start. Parking brake released. Parking brake released. Parking brake released. Let's continue our checklist. Oh, my first officer caught me. I didn't turn the beacon light on. That's why you have an efficient first officer. I just took a moment out to say hello to our viewers. Leeds-Bradford ground, GAF4 tree, ready for taxi, runway tree 2. Let's turn on our TARA mode on our transponder. Let's go to taxi lights, runway turn-off lights. We can turn off the APU. Oh. Turn up our display brightness on our displays. We have our taxi clearance. Let's taxi. Interesting. Why am I not moving? Oh, I think I know why, because I think our tug is still attached. That's pretty embarrassing. Brakes released. Brakes released. Brakes off. Brakes off. Yep. Oh, we're still being... Parking brake set. Parking brake set. Thank you. Thanks, and you can disconnect and go to hand signals. Okay, mystery solved. We couldn't taxi because we still had tug attached. What a beautiful 60-foot articulated bus. 4 entry doors on that bus. Kind of cool. Well, no blue is not entirely accurate. We still have to ding the cabin crew. Now, if we look at our configuration screen, well, the configuration screen still thinks the parking brake is on, so that certainly is not true. But once we get down here, we'll get a good takeoff configuration. Again, very European that you would taxi back on the runway and do a little turnaround here at the end. Landing lights on. I'm going to go ahead and start the clock. Right there. There's chrono. I was looking for it. Leeds Tower, GAF4 tree, ready for departure, runway tree 2. Leeds Tower, GAF4 tree, ready for departure, runway tree 2. I'm not able to remove that configuration warning. I know my parking brakes are not on, so I'm going to continue. You would never in real life continue with a warning like that, but I'm going to continue. Thank you, Flight Simulator. Our flex temp is 60, so we're going to do a flex takeoff. You can see in the upper left corner of our left display, the flex. We are set to flex temp. Had we pushed the throttles full forward, we would be in toga or takeoff go around. Five-degree up. Gear up. That's a term you would never hear in North America, contact radar director. We're coming upon transition altitude. Oh, warning for ice alert, so we'll add engine and wing anti-ice. There's 6,000 feet. As we approach 10,000 feet, landing lights can come off. Runway turnoff lights can come off. Taxi and takeoff lights can come off. And I think we are beyond our icing level, so we're going to turn the engine ice and wing anti-ice off. in the United States, anything surveyed past the United States Civil War is on is called it's surveyed on what's called the township system. And the township system consists of a pattern of grids where the streets are oriented, all the major highways and streets are oriented on a north-south or east-west compass bearing. And from a pilot's perspective, when you're flying in the western United States and you see a long straight road, you can almost guarantee it's going to be built on a cardinal compass heading, and you can use that for orientation. Well, anything in the eastern United States or anything surveyed prior to the U.S. Civil War, especially in Europe, it was surveyed on what's called the meets and bounds system. And what that means is it's a negotiation between landowners where one land meets usually